Good morning everyone. I'm going to talk about using deep learning in the edge computing-based IoT for security and privacy preservation. IoT has been widely used not only in our everyday lives but also deployed in the industry worldwide. And the numbers of IoT devices are going to rapidly increase in the near future. For example, just according to the estimation, by the year 2025, there are going to be more than 23 billion IoT devices around the world. And also, by the year 2035, each year we are going to spend $1 trillion for the IoT devices. But there is one major problem. 60% of these IoT devices are vulnerable to the cyber attacks. And it's really costing too much for the global companies, which is more than $21 trillion on just the year 2019 on the security data breach. But in the next slides, I'm going to talk about a little bit about the security and privacy issues and also a possible way to tackle this problem. You can see on the left-hand side, in 2014, there is a 7-layer architecture for the IoT presented. It started with physical devices and controllers and ends with collaboration and process. On the right-hand side, you can see different security threats on each layer are going to be happening. For example, in the first layer, you can expect eavesdropping, man-in-the-middle, botnet, etc. On the last layer, we can expect social engineering, phishing, and leakage. Also for the privacy issues, we can categorize them in 7 parts. For example, identification, profiling, and inventory attack. So we should find a way to have a method and implement it somewhere in order to prevent this attack. But where are we going to do that? And we are going to present now the edge computing. The edge computing is an extended form of cloud computing which is really done great because it processes data locally. But why we are using that instead of cloud computing? The reason are here. Imagine that there are so many IoT devices trying to capture the data and transform it with wired or wireless cables. Go to the cloud servers, it's going to have a process and then it's going to come back. So we are having a major delay here. Also, because the frequent data is going to be sent, there's also a bandwidth utilization. It's going to be high in cloud computing. Also, the response time is going to be really high, and we cannot expect any real-time reaction. There are 3 other things that I should mention here. The server overhead is going to be very high, the network congestion also like that, and also there will be a high energy consumption. So you can see the edge computing is going to be really superior. But if you're going to look deeper on that, you can see the pyramid in here. This is the layer architecture of edge computing-based IoT. It starts with the base part, which is belong to the IoT devices that can capture data. And also, this can send the data through this pyramid to the second part, which is belong to the edge computing. This can handle the data processing that we want to use. And also, we can expect here the real-time data analytics and the action response, which is going to be really helpful for us. For example, on the smart cities, we can handle the traffic, monitor them, and on the autonomous cars, we can prevent any accidents. And also, in the medical unit, you can expect finding the vital signs, track them, and prevent deterioration, for example. So this is the beneficial of using edge computing over cloud computing. Also, there is one major limit here, the data storage. In contrary to the cloud computing, it cannot provide us with a lot of cloud data storage, but it's also working like cache. Also, it's going to be sent all the data through the wired or wireless form to the cloud servers, and they're going to be used for reporting and long-term data storage and data analytics. But what are the methods that we are using? We are using the deep learning methods, but the reason is that it's a continuation of the advancement of artificial intelligence. It was really became well known after 2012, and we can categorize it as a subcategory of machine learning. It's more efficient because it has automatic feature extraction and also it can work with large number of parameters. But how can we implement that on the edge? There are 2 separate ways just for 2 things that we are going to do with the deep learning phases. The first is the training part, which is going to be done on the centralized or decentralized way. On the centralized training, the edge servers do the main thing, but in decentralized training that I'm going to talk about in the next slide, all the nodes are going to handle everything. Also, on the inference part, you can do it on the devices, but there is one problem in here. The deep learning techniques, most of them are really centralized, needs a lot of data, and also it has a huge overload on the bandwidth. So we can do it across edge devices and categorize that under the term intelligence offloading. For example, in here you can see the decentralized training scheme. It can use different nodes that we have using gossip time algorithm, which is an epidemic algorithm based on the rumors itself. It transfers the gradient updates through the different devices. This is the distributed computation for the inference. You can see that also we have in here different devices, and there is a partition in here. And the thing is here, just based on the memory and the computation limits that we have, it's going to be automatic or maybe manual. We should know about the methods that we are using. For example, in the privacy part, we are using deep neural network, convolutional neural network, generative adversarial networks. Also in the security parts, we are using these methods: convolutional neural networks, recurrent neural networks, deep autoencoders, restricted Boltzmann machines, deep belief networks, and an ensemble deep learning network. So to summarize, we are going to implement these techniques on the edge computing based IoT because it's going to be so fast in finding the security and privacy problems and going to address them as fast as we can. So thank you very much for your attention.